In this example, we will use first position method or regular FALSI method in finding the value of x that lies in the interval 0 and 2 for the function of x equal to x times sine x minus 1. For the solution in this method, the lower guess value of x, let's say AO, is equal to 0, and the upper guess value of x, let's say BO, is equal to 2. The C value in this method will be determined by this equation, B minus FB times B minus A divided by FB minus FA. I will use Excel program in my solution in this example, and we will compare the results of the iteration of this method, first position method or regular FALSI method, compared to the results of the iteration using bisection method of example number 1 of my video in bisection. Which method converge slowly or which method converge faster to the root of the function? Okay? So this is our problem. Function of x is equal to x sine x minus 1. This is the same problem of our first example using bisection method in the interval 0 and 2. So first we have to find or we have to graph this function. So here in my discussion, I have to graph the function from 0 to 10. So I have here 0, then this is equal to 1 plus this cell so that I can drag this up to 10. Okay. Then I have to enter the formula of my function. So this will be equal to, I have to click the cell times sine. Okay, type the sine, then double click times the cell of x. Okay, minus 1. So I have here negative 1. Then this is my values for the values of x from 1 to 10 or from 0 to 10. So I have to graph this. So I have to use x and y scatter plot. Okay, so this is the function looks like. So as you can see, from 0 to 10, you have 4 roots to be in this interval from 0 to 10. So we have 4 roots. But in this problem, we are going to evaluate 0 to 2. Okay, so for our iteration, so for the regular FALSI method or for the first position method, we have the initial guess value of AK and the upper guess value as BK. So I will try for my first iteration or for my initial values, we'll have 0. So we have to start 0 iteration. Then I will try 10th iteration for this discussion. So if after 10th iteration, if we still cannot get the root, so we have to proceed another iteration. So for the initial value, we have 0 for the upper guess value of our A, and for B, upper guess value of BK, we have here 2. Okay, so FAK is equal to x times sine. So double click the sine. So that is minus 1. So we have negative 1. The same with the function of C. So we have to click this cell times sine, double double click the sign. Okay, minus 1. Okay, then equal to, okay, we have times sign, double click the sign, then d minus 1. Okay, for the ck value, we have here b minus, so we have fbk times b minus a. Okay, we have to enclose this with parentheses, divided by fb minus fa. So there is an error, so I have to accept. So be careful in your formula for each cell. So I guess this is correct if each. Okay, so that is 1.0997501. Okay, so we have to check. So as what I've said, this method is also called guess and check method. So we guess the value for our lower guess and our upper guess value for x as a and b, then check if the sign of if a and if b, or fa and fc, sorry, have an opposite sign, or the sign of fc and fb if they have opposite sign. So here the function ak and function ck have the same sign, so we have to check this one. fck and fbk have opposite signs, so the root lies between these points. So our lower guess will be equal to the function, the value of ck, and for our upper guess will be the value of b. So we have to drag this. You can drag this up to 10th iteration, but you have to be careful because we need to check the sign of the function. So here again, this one, they have opposite signs, so our next lower guess value will be equal to a, then our upper value will be c. Okay, so I have to okay, we have to set this one so up to 6 decimal places. So up to 6 decimal places. The same with the bisection method. Okay, so next is this one. Again, for the third iteration, our upper value or our lower value will be the value of a, then our upper value will be the value of c. Okay, then the same. So see, the function of c becomes 0 at third iteration. So it easily, or it converge faster using this method compared to bisection method. I guess we already try up to 21 iteration to make f equal to 0 or to find the root, which is also equal to 1.114157. Okay, so we will have to continue. We will try. So we have here this one and also this one. So I guess we have to stop up to fourth iteration. So it converges faster. So therefore we will say x is equal to 1.114157. So this is now the root of our function. X is equal to x sine x minus 1. So it converges faster compared to bisection method. So next we have to graph these values. So we have to use scatter plot, the x and y scatter plot. Okay, we have to edit this. So okay, we have to select data. Then I have to remove this. Remove. Then for the x value, okay, this will be here. Then you press comma, then comma. Okay, then for the y values, for our functions, we have this one, and comma, then comma, then so okay, we have this to edit the axis. So okay, I have to consider 1 decimal places. So the interval is by 0.5. Here we can also edit here. So this will be whole number. So I will input 0. Okay. Or if you like to include series, so we can change that one. Your series data, if we rename this one to our function f of x. Okay, so it changed to function f of x. So if you like to have a chart title, so it's up to you. Then I have to format this one. So I will try to find the best fit of my function. So I guess 30 degree is okay. Okay, so between 0 and 2, so this is now the location of the root. So okay, this is now the result of our solution in finding the root of the function between 0 and 2 interval. This graph shows a bigger picture of the interval between 0 and 2. Okay, from our solution, as you observe using postposition method or regular FALSI method, it converged faster to a root which is equal to 1.114157 up to 4 iterations only, compared to the bisection method. For this problem, it reaches up to 21 iteration. So it converge slowly compared to postposition method or regular foci method. So I hope you already understand the difference in using bisection method and postposition method or regular foci method in finding the roots of a function or the roots of a nonlinear equation system. Okay, so thank you for your time in watching this video, and I hope you understand. Thank you and God bless.